all firewall devices can be configured in several network connection architectures. The configuration that works best for a particular organization depends on three factors: the objectives of the network, the organization's ability to develop and implement the architectures, and the budget available for the function. Packet filtering routers are configured to reject packets that the organization does not want to allow into the network. This is a simple but effective way to lower the organization's risk from external attack. The drawbacks to this type of system include a lack of auditing and strong authentication. Screened host firewalls combine the packet filtering router with a separate, dedicated firewall, which retrieves information on behalf of other system users and often caches copies of web pages and other needed information on its internal drives to speed up access. This shows a typical configuration of a screened host architecture. The Bastion host contains two NICs, network interface cards. One NIC is connected to the external network and one is connected to the internal network. Implementation of the Bastion host architecture often makes use of network address translation. NAT is a method of mapping valid to create another barrier to intrusion from external attackers. Organizations that need a large group of addresses for internal use will use the private IP address ranges reserved for non-public networks as shown here. This shows an example configuration of a dual-homed firewall that uses NAT to protect the internal network. The dominant architecture today is a screened subnet firewall used with a DMZ. The first general model consists of two filtering routers, with one or more dual-homed Bastion hosts between them. In the second general model, the connections are routed as follows. Connections from untrusted networks are routed through an external filtering router. Connections from untrusted networks are routed into and then out of a routing firewall. Connections into the trusted internal network are allowed only from the DMZ Bastion host servers. Another facet of the DMZ is the creation of an area known as an extranet. An extranet is a segment of the DMZ where additional authentication and authorization controls are put into place to provide services that are not available to the general public. SOCKS is a protocol for handling TCP traffic via a proxy server. The SOCKS system is a proprietary circuit-level proxy server that places special SOCKS client-side agents on each workstation. A SOCKS system can require support and management resources beyond those of traditional firewalls. The DMZ can be a dedicated port on the firewall device, linking a single Bastion host, or it can be connected to a screened subnet as shown here. The most important factor is to answer which firewall design provides the required protection. The next important factor is cost, which may keep a certain make, model, or type of firewall out of reach. Good policy and practice dictates that each firewall device, whether a filtering router, Bastion host, or other implementation, must have its own set of configuration rules. The most important thing to remember when configuring firewalls is that when security rules conflict with the performance of business, security often loses. Best practices for firewalls. All traffic from trusted network is allowed out. Firewall device never directly accessed from public network. Simple mail transport protocol, data allowed to pass through firewall. Internet control message protocol, data denied. Telnet access to internal servers should be blocked. When web services offered outside firewall, HTTP traffic should be denied from reaching internal networks. Firewalls operate by examining a data packet and performing a comparison with some predetermined logical rules. The logic is based on a set of guidelines programmed by a firewall administrator or created dynamically based on outgoing requests for information. Most firewalls use packet header information to determine whether a specific packet should be allowed to pass through or be dropped. Let's assume a network configuration as illustrated here with an internal and external filtering firewall. Firewall rules are applied. This table shows the port numbers associated with several known protocols to build a rule base. The first rule prevents spoofing of internal IP addresses. The rule that allows responses to internal communications comes after the four rules prohibiting direct communications to or from the firewall. In the outbound rule set, the first rule allows the firewall to access any device. Because this rule is on the outbound side, you do not need to worry about external attackers. The next four rules prohibit access to and by the firewall itself, and the remaining rules allow outbound communications and deny all else.